Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering geometry, lessons 5-1 and 5-2, on mid-segments and bisectors and triangles. We have lots of vocabulary and important ideas to cover today, so let's go ahead and get started. We begin today with the idea of a mid-segment. A mid-segment is exactly what it says, a segment that goes through the middle of a triangle. It connects the midpoints of two sides. So if you notice, AD here is the same as DB, they have the hash marks, and AE is the same as EC. So this point here, E, and this point here, D, is the middle of each of those lines. And when they connect them, what they get is the mid-segment right here. You can do that for any of the sides of a triangle. There are actually 3 mid-segments in a triangle. I drew in the midpoint here of F, and BF and CF are the same, so you can draw this mid-segment here, EF, and you can also draw the mid-segment DF as well. So what's important to remember about a mid-segment is that the mid-segment and the third side, so it comes from points D and E here, the third side is BC. They are actually parallel, and DE is half of BC. And that's what this shows here. All mid-segments are half of the third side and parallel to it. Another kind of proof that we use in geometry is called a coordinate proof. And these proofs use coordinate geometry, and they put shapes and figures into a coordinate plane in order to solve the proof. It is almost always best to try to utilize the origin when you're doing this if you can, 0, 0. All right, we move on to lesson 5-2 now, and the perpendicular bisector theorem. It says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So PM here is the perpendicular bisector of AB. Notice how the left side and the right side are the same, and this is a right angle here. So what that says is any point along MP here, including point P, is equidistant from the endpoints. And that's what it shows over here on the right. AP and BP are both equal to each other. The converse of this theorem flips it around, and it starts with if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. This leads us to the idea of distance from a point to a line. It is very important to remember when you are trying to find distance here that you want to use a right angle whenever possible. So this here is a right angle. So you measure from the point to the line at a right angle to the line. In this particular case, it says that AD is the bisector of angle CAB. So this angle here and this angle here are the same. And so what that shows us is that from point D, this side here and this side here will also be the same distance. Which leads us to the angle bisector theorem. Up here on the top, it says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. And that's what we just proved. Notice this angle here and this angle here are the same. So CB is the same as AC. And the converse of that says that if CB is congruent to AC, then C is on the angle bisector, and angle APC is congruent to angle BPC. Good luck, everybody. I hope you guys all do great.